Hello there. Welcome once again yet to another session of Simply Learning. And today we would like to look at factorization. You're going to look at factorization. And the method of factorization you're going to look at is what we call the difference of two squares. Whereby this difference of two squares factorizes terms which are squared and they are subtracting each other. In that way, you see that the definition can be noted that if I have a squared minus b squared, then this will factorize to a plus b times a minus b. That is what the factorization is all about. You would also realize that one can also write it like this. If I have a squared minus b squared, I can have it in terms of a minus b times a plus b. You can either start with a subtraction or start with addition. If they are different terms or letters, you can have, for example, x squared minus y squared is equal to x plus y times x minus y. Still, with this, you are looking at what we call the difference between two squares. So straight away, since we are simply learning, let's go for examples and take a look at how we can use this method. So for examples on this method, we can say, if I have, for example, factorize the following, factorize the expressions. And the first expression, Roman one, is if I'm factorizing x squared minus 4y squared. To start with, one needs to know that this is actually x squared minus 2y, but the whole of this is squared. So the entire bracket behaves like one term. So I can now take this to behave like a, then the whole of this to behave like b. And for that reason, if they behave like that, then I'll have x squared minus 2y squared is equal to x plus 2y, then times x minus 2y. And that will become our factorization for that term or for that expression. The second example I can take a look at on this. If I have p squared minus 16q squared, then I can write this as p squared minus 4 of q, the whole of this put in a bracket, to the square. So that it clearly shows you that you have a difference of two squares. So therefore, this expression can take me to p squared minus 4q to the square is going to be the same as p plus 4q times p minus 4q, and that will become our solution. Okay. Another example, if I have Roman 3, remember, if you need to understand best these videos, you need to watch them over and over again if you've missed one of the concepts. For example, if I have 81 minus 121 of q to the power 4, check this out. This is the same as writing 9 to the square minus 11q to the square, but the whole of this now raised to the power 2. So that if this 2 comes into brackets, the q will become power 4, then 11 will become 121. So if I factorize this, what will I realize? I will realize 9 minus 11q squared times 9 plus 11q squared. In case the 11 was another square number, then you can go and be in position to factorize it further. And then you have whatever you want to have. as your solution. Okay. Example 4. If I look at example 4 can take on the form 16 of x to the square, y to the square, minus, for example, 9. Then one has to first confirm that this is actually 4xy, the whole of this raised to the square, minus 3 raised to the square. So that this can take us to 4xy minus 3 and brackets 4xy plus 3. These are all solutions to factorization of terms using the method of what we call the method of the difference of two squares. So lastly, we can have an illustration on this. The last example I can give on this can be, if we have, for example, a term like, let me call this example 5. We have 3 minus 3f squared. One may wonder, is this a difference of two squares? First of all, there are two common factors, 3. So if you factorize out 3, you would realize 1 minus f squared. Now 1 can be squared, can be cubed, can be raised power, any power, but still you get 1. So there is a silent 1 squared there. So one can write this as 3 into 1 squared minus f squared. When you simplify this, you'll get 3 into 1 minus f, close brackets, into 1 plus f. And that's how we can factorize this kind of expression. So lastly, on this one, I can have 100x to the square minus 1. Still, this one can be considered having 1 as a square, which will take us to 100x squared minus 1 squared. And this would give us 10x plus 1 times 10x minus 1. That is how you factorize that expression using what we call the difference of two squares. Since we are simply learning, I need to confirm that you've really learned. So allow me stop here for today and let you have this simple exercise to check it out on your own. The first number is going to be 4d squared minus 9e squared. Then the second number can be 81 minus s squared. Then the third number can take on the form x squared y squared minus z squared. And then the fourth number can take on the shape of p squared q squared minus 9. I'm still Hamza Rwama, who has been taking you on in factorization today. And today we have discussed what we call the difference of two squares. Under factorization, just keep it here. Keep it at Simply Learning. Go like our channel, go like our YouTube channel, go like our accounts, subscribe, and share to everyone. Enjoy the mathematics. Have a good day.